This is the last part of LCD tutorial. In the first two parts, I have shown how we can hook up the LCD with an Arduino. The first part was without I2C adapter and the second part was with I2C adapter. You can see those videos if you want to know from the very beginning about LCD. In today's video, I will show how we can print our sensor value on the LCD. I will use this ultrasonic sensor to measure the object distance and will print the distance on the LCD. Let's see the working principle of ultrasonic sensor first. Ultrasonic sensor work by sending out a sound wave at 40 Hz frequency, which is above the range of human hearing. The sound wave travels through the air until it strikes an object. When the sound wave hits an object, it is reflected back to the ultrasonic sensor. The sensor then calculates the time it took for the sound wave to travel to the object and back, and uses this to determine the distance of the object. This is the most popular sensor for measuring distance and making obstacle avoiding robots with Arduino. This sensor has 4 pins: VCC, ground, trigger and echo. At first, place the ultrasonic sensor on the breadboard like this. Then we'll hook up the sensor with Arduino. Connect VCC of the ultrasonic sensor to 5V of Arduino. Connect trigger pin of ultrasonic sensor to Arduino digital pin 11. Connect echo pin of ultrasonic sensor to Arduino digital pin 12. And the last pin of ultrasonic sensor, which is ground, will be connected to ground of Arduino. Now we will connect the LCD display. This is LCD display with I2C. It has only 4 pins: ground, VCC, serial data and serial clock. The ground pin will be connected to ground. Here we can use the same ground pin which we used for ultrasonic sensor. The VCC pin will be connected to 5V. Like the ground pin, here we can use the same 5V pin which we use for ultrasonic sensor. Connect SDA of LCD display to analog pin A4 of Arduino. And lastly, SCL of LCD display to analog pin A5 of Arduino. Let's write the code. In Arduino, like other leading programming platforms, there are built-in libraries that provide basic functionality. We have to include oil library and liquid crystal library. Then we are setting the LCD address. To use the Arduino pins, we need to define which pin is being used and its function. Here we are defining ultrasonic sensor trigger pin 11 and echo pin 12. We need to declare global variables and instance to be used later on. A variable allows us to name and store a value to use in future. Here adding data type long and name 2 variables, duration and dist. Now come to the void setup section. We are adding LCD backlight function to turn on LCD backlight. Then by pin mode function, we are defining the trigger pin will function as output and echo pin will function as input. After end of voice setup, let's start the loop. It is the main function and it's run in a loop over and over again. At the beginning of the loop, we are making trigger pin state 0 by digital write function and then making 5 microsecond delay. Now we'll make the trigger pin high to create sound wave. We'll keep the sound wave for 10 microseconds. Then we'll turn off the sound by making trigger pin low. The sensor then calculates the time it took for the sound wave to travel to the object and back. Here in the code, we are getting this duration by pulse in function. To get the distance, we'll divide the duration by 2 as the sound wave traveled 2 times of the object distance. Then we'll further divide it by 29.1. Sound travel 1 cm in 29.1 microsecond. That's why we'll divide by 29.1 to get the result in centimeter unit. In the beginning of the print, we are setting our cursor at the first position of the first row. The double quote symbol is used to delineate a string of text. We are printing the word distance in the first position. So whatever you want to print on LCD as a text, it will be inside the double quotes. After that, we are setting our cursor to the first position of the second row. We'll print dist variable value, which is the distance. At the end, we will print our measuring unit of distance and will make 1000 microsecond delay and clear the LCD. Here end of loop, and this loop will continue. Now we will upload the code to Arduino. I will share the code and the library for LCD display in the description. Copy the code and open to your Arduino IDE. Select the board and port correctly from the tool option and then upload the code. After done uploading, let's test. Thanks for watching. You are welcome to see some other die videos from my channel. And if you have any questions, you can comment.